Okay, hi everyone. My name is Arvind Jaganath and I'm a Senior Product Line Manager at VMware. So I'm leading a lot of infrastructure projects at VMware, basically responsible for platform enablement. And one of the things I have been looking into is persistent memory and memory technologies in general. So today I'm going to sort of give you a glimpse of what VMware is planning or sort of looking into. We are still in, I'll admit, we are still in some early stages with CXL, but we are definitely committed. There is a lot of work that we are already planning, and we think that this is going to be our future going forward. So this is a standard disclaimer. So basically it says that this is still work in progress and no commitment. So if you look at some of the VMware competencies, right? So again, I'm glad to be starting as one of the software companies. So we are a completely software company. We are a virtualization company. We have a hypervisor operating system, which is completely built from the ground up. So basically, the hypervisor provides controls and manages the workloads that are running. It has insights into every single aspect of the workload. Essentially, the compute resources that are consumed, the storage resources, the memory resources that are consumed. So the hypervisor, the operating system is capable of completely controlling how workloads are being managed. So as a virtualization platform, I would say that it's an advantage because now anything you build underneath makes the operating system completely agnostic of the underlying hardware. So what that means is you could go on building all kinds of different hardware innovations underneath, but eventually the operating system could stay independent and it needs absolutely no changes. So you can bring anybody can bring their operating system along with the workloads. They can just install it as a VM and they're just ready to go. And they can take advantage of the underlying hardware innovations. So the other core value proposition for VMware is DRS. So DRS is distributed resource scheduling. So basically, VMware was built with a premise that we will try to manage and the workload and make sure that across a cluster there is holistic management, in the sense that we monitor how hardware resources are consumed, how our compute, the CPU and memory resources look, and we'll ensure that the workloads are always get the consistent performance they require. So DRS is extremely important in that respect, and VMware already has that built in. And you will see that a lot of the current work that we are doing, we are constantly adding heuristics into our DRS algorithm. So the distributed resource scheduler is so important that it needs to be constantly updated, and we make sure that any new hardware technology that comes into picture actually has some component of it added into the DRS. VMware is also a strong ecosystem. So basically, we have partners across the board. So we partner with OEMs, CPU vendors, IO vendors, memory vendors, storage arrays, storage vendors. So across the board, we work really closely with all these partners. If you look at the VMware VCG, which is the HCL, you will see partners, in every single aspect of the industry. So the bottom of the slide just shows that some of the things that represent some of the hardware innovations, right? So um, in ESX, we have been enabling things like pass-through devices, and we have also been able to take some hardware capabilities and bring innovations like dynamic direct path IO. We also recently worked on a lot of the GPU related work. So things like GPU sharing and assignable hardware. And most recently, we've been working on smart NICs and accelerators. So this is, most of you must be familiar with this. I won't spend a lot of time. Essentially, the idea is that growth of data is inevitable. It's growing at a very fast rate now than ever before. So I mean, IDC predicts 30% of global data will be real time, and that's why it's important to actually make key innovations in the memory space, because you want your workloads to be running in memory to get that real time kind of performance. So things like AI, ML, and big data analytics, there's just a tremendous amount of data being generated, and we need the corresponding technology that can address this growing data, that can help process this data. So, so if you see on the left, there are some trends, and on the right, you will see what customers need. So basically, customers are looking to get more insights from their data, which means that they want to make sure that they can get all the data that's lying there. They can actually process that fast and get more insights from them so that they can apply it back to their business and improve their business. So, and again, another key point on the left is basically that software has been leading the innovation and hardware is catching up. So there needs to be some technologies that actually, bridge that gap and make sure that hardware is easily available to be used for all these new applications like big data analytics. On the right, you will see that the customer needs, in the sense that customers they have some requirements in terms of being able to scale infrastructure or bringing more in-memory computing, and one of the primary issues with memory is that it's expensive. So DRAM is expensive. In fact, go to any configurator, Dell or HP's, and try to configure a server, and you will find that DRAM forms sort of at least 30 to 50% of the entire server cost for customers. And finally, another advantage of hypervisor and the operating system is how we are building on some of the monitoring capabilities and adding it to DRS, which I mentioned. So the VMware's big memory vision itself starts with software tiering. So about 2 years ago, we started on this journey of bringing together this tiering architecture. So we actually made sure that we can take advantage of the different tiers that are being used in the underlying memory. So we started working on algorithms that can change our memory management capabilities. So we are making the memory management more aware of the different tiers, and we are ensuring that we can do page placements efficiently, and we can provide cost benefits and capacity benefits to our customers. So essentially with VMware, so with VMware, the idea is to make this as transparent as possible. So ESX will provide a single address pool, and customers don't have to actually look into special configurations, make sure how or be bothered about how the different tiers are being used for their workloads. So VMware will ensure that the operating system will actually handle everything related to the tiers and hide all the complexities underneath. And all that we get, for example, you can run a workload from 3 years ago and just transfer it to a new tiered memory architecture, an ESX that has tiered memory enabled, and you can run the same workload with no changes, absolutely. So that's the key point here. So basically, no changes in the application, no guest OS changes. So bring everything as is, Windows or Linux, and run your workloads without any configuration changes. The first 2 points, higher density, more capacity, lower TCO, they are all the problems that we are trying to address with CXL, right? So we need the memory expansion solution, and DRAM is expensive. It doesn't satisfy the density, and that's why we are today we are talking here, right? So another goal of VMware is the ESX is to ensure that performance degradation is minimal. So we want to make sure that the hot and cold pages replacements are done efficiently, and we can use a lot of the heuristics, including proactive page placements, to ensure that we get absolutely no performance degradation. So I mentioned that some of the tiering heuristics would be fed to DRS. So DRS and vMotion can always mitigate risks, which means that if you have a cluster with tiered memory on all the hosts, DRS can ensure that it's tiering aware and make decisions on the right host on which to place the workload. So another advantage is of doing it in ESX is I mentioned in my first slide that we are aware of exactly how the workloads are running and how they are consuming the various tiers. So we are at the best position of ensuring a consistent performance and making sure that there is fairness across the workloads, which means that you can't have a rogue VM or a rogue workload completely trying to occupy the DRAM and consuming the DRAM. We make sure that we give enough capacity to the workloads that demand the performance, and make sure that across the board we achieve more consistency. So I mentioned zero configuration changes, and then one of the aspects we are working with Intel on is a processor-specific monitoring. We work with them closely on, and we recently released a feature called VMMR, memory monitoring and remediation. Basically, it takes some fine-grained statistics from the memory architecture itself on the CPU, and then make sure that those can be rolled up at the ESX and vCenter levels, so that customers get more insight on the workloads in terms of things like memory bandwidth or latency and miss rates, read and write bandwidths, etc. And the good thing is it's available on a per VM basis, which means that admins are now able to look at each VM separately, and they can sort of gauge and ensure that their workloads are getting the right amount of tiers, and make sure that they are actually sizing it properly. So this is basically a diagram which shows that we did make the changes right in our kernel, so which means that there is no change required. So we changed our memory management and DRS schemes, for example, to be tiering aware, and the hypervisor just is aware of the tiering, and then it makes sure that it gets all the workloads get consistent performance. So the underlying memory could be, DDR or any lower cost memory, including Intel Optane persistent memory. So this is another diagram. This basically, our future is, even though I don't show it, so essentially we want to see if we can do shared kind of accesses and sort of go across the cluster. So in the first phase, we are looking into DDR and Intel Optane, but going forward, we'll also be looking into CXL attached DRAM or NVMe and pooled NVMe. So we do have quite a few options, and we are currently investigating a lot of these other technologies also. So there are various tiering approaches. So you could have, basically each of those blocks represent a tier. So you could have the ESX kernel consume the various tiers. So you could have DRAM and Optane, for example, or another slower memory. For example, one of the options could be you could connect a CXL to DDR4 to reduce your cost, and you could actually have tiering in that sense. You could have tiering between DRAM and NVMe. You could also have 3 tiers. So ESX already has that capability. It has implemented the algorithms. So it's not a huge lift to add an additional tier. And then I mentioned remote memory and host sharing. So which means that you could have the tiers used in a sort of shared mode, which means that you could pool memory across hosts, and then we could have a scheme where they use shared memory and as a separate tier. So CXL attached device or pool is another option, and finally we could have NVMe or Fabric also. So with CXL 2.0, we are looking into providing the same single uniform memory address space with the ESX host. We'll be looking into providing other tiers which are CXL attached. It could be DRAM or it could be remote slower memory. We will also definitely work on CXL switching, and also will look into definitely work with a lot of vendors, planning to work with all the memory vendors and some of the OEMs to see how we can bring some of these CXL innovations. And this is my final slide. So how does it all fit? So essentially, on the right, you see VMs using pages, and there is page placement going on. Basically, the tier is chosen for each page, and we have granularity in that sense, where we can tier individual pages across different memory hardware. And then the VM monitor monitors bandwidth and actually feeds it to the host monitor, and then we start with some tier sizes, and we can dynamically change the tier sizes across the VMs, and then once the host monitor set, it can look globally into across the cluster, and it can the DRS can kick in and make sure that the VM is getting the required minimum performance, and it can make sure that it can move the VM to another host if required. So that's about it, and I'll now pass on to Manoj. Yeah, any questions? Sure.
At VMworld, you guys announced Project Capitola,
Yes.
and it was similar, but you didn't mention it today.
Yes.
So what is the connection or disconnection there?
Yeah, great question. Yeah, so Project Capitola is still in our plans. So in the sense that we did go ahead and implement tiering algorithms within the ESX. So it's definitely not something something that we throw away. We'll definitely leverage it for other types of tiers, other memory technologies. As you heard from probably most of you know, the plan with Intel Optane is that they plan to keep it until 2025 and then support it, support every single Optane that is sold for 5 years, which means that we still have enough run time with it, and we can still go out with Project Capitola with Intel Optane. We will have the feature. We are definitely planning to have the feature itself. Now, it's really up to the customers. I mean, we have to look into talking. We are still negotiating, talking to OEMs, trying to find out, what their plans are, because, ultimately, the Optane plans depends on OEM's plans, and then we can only influence so much. But from a software perspective, we have the code, we have the tiering architecture in place, and even if we decide to go out with Optane, we are still ready, and Project Capitola can be released.
Hi. You might have mentioned it before, but I was here late. I saw one of your slides mention CXL over a pool of NVMe. CXL is a memory-based interface.
Yeah.
How does that work with CXL over a pool of NVMe? And
Yes.
do you see that NVMe to be an NVMe flash?
Yeah. So great question again. With CXL and NVMe, obviously it's not directly attachable. So we are looking to see if we can use an intermediate technology, maybe from a vendor. So vendors are coming up with some really smart schemes, such as FPGAs, for example, or smart ASICs. A lot of them are building their memory along with such an intelligent hardware component, so which can actually do some of the translation. So you might have a vendor an NVMe vendor who might actually translate for us and actually be an intermediary, so that it exposes memory to us. Did I answer the question? Okay, go ahead. Yeah, go ahead.
So when you say expose the memory, did you mean expose as a DRAM or expose the flash?
No, expose as a DRAM.
Expose the DRAM.
Yes. Yeah.
Hi. So you said in the kernel, basically most of this implementation is done in the kernel.
Yes.
And so there is tiering, there is tier identification in the kernel. So is this tier identification done through some kind of OEM identification that is provided in the kernel, or are you guys using, as you said, bandwidth, monitor tier bandwidth? Are you kind of measuring bandwidth and then identifying the tiers?
Yes, we are doing that. So we are actually measuring bandwidth. We are measuring usage. I mean, simple schemes like LRU. We are adding more heuristics to the basic LRU. We are making sure that we identify locality and
No, so
yeah.
My question was more about the classification of the memory devices. So how do you identify in the kernel itself which device belongs to which one?
Yeah, it's mainly based on latencies. So latency and bandwidth. So initially you can think of it as when the kernel comes up, it can look into all these various tiers and then sort of have a basic measurement of latency and bandwidth and identify, and then classify it as different tiers. All right. Thanks a lot.